Okay, let's unpack this. I want you to think about your last meal.
Right. Could be literally anything.
Yeah, maybe it was toast, or maybe a quick salad, maybe a burger.
Hopefully something good.
Right, hopefully. You ate it, you enjoyed it, and then you just moved on with your day. We all kind of treat food like it's just, well, like just there.
Exactly. It just magically appears on a grocery store shelf.
Yeah, all wrapped in plastic,
Yeah.
completely divorced from its origin story. But if you actually take a second and pull back the curtain, the how and the where of that food getting to your plate is probably the most complex system humans have ever built.
It really is. I mean, we tend to look at a city skyline and think, wow, look at how humans have engineered the physical world.
Sure, skyscrapers and bridges.
Right. But the real engineering happened in the dirt thousands of years ago. Agriculture is basically the original geoengineering project
I love that way of framing it.
because it's not just about, scattering seeds and hoping for good rain.
Yeah.
It is a deliberate, massive manipulation of the planet just to keep billions of us alive.
And that deliberate manipulation is exactly our mission for this deep dive.
Yes, it is.
We aren't just doing some boring textbook review of farming today. We're going to look at the actual machinery behind the food.
The global patterns.
Exactly.
Yeah.
Why do we grow rice in wetlands but wheat on the prairies? Why is your morning coffee almost certainly hand-picked, while your corn is harvested by an autonomous robot?
It all comes down to specific, deliberate systems.
Right. We're looking at the global patterns that decide what ends up on your plate. But to really see those patterns, we have to start with a definition. Because farming is actually a bit too vague of a word for what we're talking about.
It is. We really need to talk about agriculture.
Is there a functional difference there?
Oh,
Or are we just splitting hairs over vocabulary?
No, it's a crucial distinction. Agriculture is the deliberate practice of planting and harvesting domesticated plants and raising domesticated animals.
Deliberate being the key word there.
The absolute key word. Think of it this way. You can walk into the woods right now and find a wild blackberry bush. If you pick those berries, that's foraging. That is just nature doing its thing.
You're just taking what's already there.
Right. But if you dig up that bush, move it to your backyard, water it, and prune it to make the berries bigger.
Yeah.
That's agriculture.
So it's the difference between finding a tool and building one.
Exactly. And we built these tools biologically. This is the whole concept of domestication.
Which means taking a wild species and changing it to fit our needs.
Precisely. I mean, the corn you eat today looks absolutely nothing like its wild ancestor.
Right, teosinte.
Yeah, teosinte, which was basically just a tiny grass with a few hard kernels. You couldn't even really eat it the way we eat corn now.
But humans spent thousands of years selectively breeding it.
Year after year, picking the biggest seeds, we engineered it to be giant, sweet, and yellow. We altered the biology.
So we've hacked the plants, we've domesticated the animals, but here is where the reality check comes in for all this human ingenuity.
The physical environment.
Right. Even though we've engineered these super crops, we can't just drop them wherever we feel like it. Like, I can't just buy a plot of land in Antarctica and decide I'm going to be a pineapple baron.
You could certainly try, but you'd go bankrupt very quickly.
It's not going to end well.
Not at all. And this brings us to what we call the rules of the game. We like to think human technology conquers everything, but in agriculture, the physical environment still holds the ultimate veto power.
So who are the gatekeepers here? If I want to start my pineapple empire, what is actually stopping me?
The very first gatekeeper is the soil itself. You can't just plant things in plain dirt.
There's a difference between dirt and soil.
A massive difference. You need soil that is biologically active. It has to be nutrient dense.
Which perfectly explains why the Great Plains in the U.S. are essentially the breadbasket of the world.
Oh, absolutely. That soil is incredible. It's deep, it's dark, it is packed with organic matter.
The perfect foundation.
Right. Now compare that to Antarctica or even parts of the high Arctic.
Where I'm trying to grow my pineapples.
Exactly. Up there, the soil is either completely frozen or it's simply non-arable. It lacks the basic nutrients to support complex plant life.
So before you even look up at the sky to check the weather, you have to look down at the ground beneath your feet.
Soil quality is factor number one. It dictates everything.
Okay, so let's say I find some really good nutrient-dense soil. But the land is jagged, it's hilly, it's just a rugged mess.
Well, then you run into the second factor, which is topography.
The shape of the land.
Right. And the shape of the land doesn't just give you a nice view. It dictates the actual technology you are able to use.
How so?
Think about large-scale cropping. If you want to grow wheat or corn at a massive scale, you need massive machines. Combines, tractors, massive sprayers.
And those machines need flat land.
They do. They cannot drive up a cliff.
So generally speaking, flat land equals crops.
Generally, yes. The Great Plains are wonderfully flat, so they get the crops. But what happens if you go to the Highlands of Scotland or parts of Ireland?
It's incredibly rugged.
Very rugged. You can't run a combine harvester sideways on a steep hill. It'll roll over.
Yeah.
So what do you do with that land?
You bring in the biological combine.
Exactly.
Yeah.
Sheep, goats, cattle.
Animals handle topography much better than wheels do.
They have legs. So the physical landscape essentially sorts the farming for us. Flat lands usually go to large-scale crop production, and rugged lands usually go to livestock grazing.
It makes so much sense when you say it out loud, but you don't usually think about a sheep being a technological solution to a steep hill.
It absolutely is, though.
Okay, so we have soil and we have topography. Now we have to talk about the invisible boss fight in all of this.
The climate.
The climate. And let's be super clear here. We are not talking about the weather.
No, weather is just the daily fluctuation. A rainy Tuesday doesn't change your entire crop choice.
Right.
We are talking about climate, which means the long-term predictable patterns.
It's like the difference between your outfit for the day and your entire wardrobe.
That is a perfect analogy. Agriculture depends on the wardrobe.
So walk us through the main wardrobes that the planet wears.
Broadly speaking, you have 3 primary climate zones that dictate global food production. First, you have the tropical zones.
So think of the belt right around the equator.
Exactly. Central America, the Amazon basin, South Asia.
Hot and wet.
Consistently hot and consistently wet. There is no frost.
Ever.
So what grows there?
This is where you get your thirsty crops. Rice is the big one. It needs massive amounts of standing water.
Sugarcane, too. Yeah.
Sugarcane, bananas, coffee. These are plants that would die in a week in a dry climate, but they absolutely thrive in the constant heat and humidity of the tropics.
Got it. So then moving away from the equator, you have the dry zones.
The deserts and the arid steppes, parts of North Africa, Central Asia, the American Southwest.
Places where the biggest risk is drought.
Right, and you just can't rely on rainfall to sustain crops here. So humans adapted.
This goes back to the sheep on the hill, doesn't it?
Yeah.
Exactly. Instead of forcing crops to go in the sand, this is where you see nomadic herding and livestock. You use the land for animals, because animals can physically move to find water.
The crops are stuck in the ground. If it doesn't rain, they die.
But a herd of goats can walk to the next oasis.
That leaves the third zone, which is probably the one most of us in the West are familiar with.
The moderate zone.
The Goldilocks zone.
Mild winters, warm summers, a decent amount of rain. This covers the edges of the tropics and the mid-latitudes.
This is where you get your general crop production.
Right. Your mixed farming,
Ugh.
grains, root vegetables, apples, pears. It's the most forgiving climate overall.
But there is one specific subtype of climate within this that I really want to zoom in on, because frankly, it feels like a cheat code for agriculture.
You're talking about the Mediterranean climate?
Yes, the vacation climate.
It really is the vacation climate.
But it's not just located in the Mediterranean basin, right?
No, that's just the namesake.
Yeah.
You obviously find this specific weather pattern
Right.
in places like Italy and Greece.
Right.
But you also find it in coastal California, central Chile, parts of South Africa, and southwestern Australia.
And the weather pattern itself is somewhat backwards compared to everywhere else.
It is unique. In most moderate places, you get your heavy rains in the summer when it's warm. But the Mediterranean climate has hot, completely dry summers and then mild, wet winters.
So the plants bake in the summer.
They do. And that environmental stress, that intense summer heat and lack of water, is actually perfect for some very specific high-value crops.
This is where the really good stuff comes from.
Olives, grapes, citrus, figs.
The charcuterie board crops.
Exactly. Vines and olive trees actually love that summer stress. It forces the plant to dig deep for water, which concentrates the sugars and the flavors in the fruit.
That makes so much sense. So if you've ever wondered why a bottle of wine from California tastes similar to one from Tuscany,
Or why Chile is suddenly a massive exporter of grapes.
it's because they're climatological twins. They share that exact same Mediterranean wardrobe. Okay, so we've got the board set up. We know the rules of the game: soil, topography, and climate.
Those are your constraints.
But humans are clever. We don't just accept the rules of the board, we constantly try to maximize our score.
We always want higher yields.
Right. And this leads us to the two main strategies of global farming: intensive and extensive agriculture.
This is the fundamental divide in human geography. It sounds like a technical academic concept, but it's actually really simple if you think about it like real estate.
Okay, I'm listening. Give me the real estate pitch.
Intensive agriculture is like owning a high-rise apartment building in downtown Tokyo.
Very expensive. Very small.
Exactly. You only have a tiny footprint of land. So to make it profitable, you have to invest a huge amount of money, technology, and engineering to pack as many people, or in the case of farming, as many calories into that small space as physically possible.
So you build up. You maximize the output per square inch.
Right. Now, extensive agriculture is the opposite. That's like owning a sprawling 50,000-acre ranch in Montana.
Where land is cheap.
Land is cheap and incredibly plentiful. You don't need to spend millions building a skyscraper. You just spread out over the horizon.
So the entire definition really hinges on that ratio of inputs to land.
That is the dividing line. Intensive means high inputs, lots of labor, lots of capital, massive amounts of fertilizer and machinery, all concentrated on a small plot of land to maximize the yield.
And extensive.
Extensive means huge tracts of land with very low inputs. You're relying mostly on the natural fertility of the soil and the sheer size of the farm, rather than pumping money into every single acre.
Let's make this concrete. Because when I hear the word intensive, I immediately picture a massive industrial factory farm. But it doesn't always look like that, does it?
No, and that is a really common misconception. Intensive doesn't always mean industrial. Let's look at a style called market gardening.
Which is also sometimes called truck farming.
Yes.
And just to be absolutely clear for everyone listening, this has nothing to do with growing Ford F-150s.
No trucks involved in the growing process. The word truck in this context actually comes from an old Middle English word meaning to barter or exchange commodities.
Ah, okay. So what is market gardening?
It is the intensive production of fruits, vegetables, and flowers. Think of the massive salad bowl regions of California, or those endless high-tech greenhouses in the Netherlands.
This is intensive because of the money involved.
Because of the money and the location. Market gardens are usually located very close to dense urban markets.
So the land itself is prime real estate.
Extremely expensive real estate. And the farmers locate there so their fresh produce doesn't spoil during transport to the city. But because that land is so pricey and their plots are relatively small, they have to absolutely blast it with inputs to turn a profit.
They need maximum tomatoes per square foot.
Right. They use specialized greenhouses, drip irrigation, intense synthetic fertilizers. They can't afford for a tomato plant to yield 5 tomatoes. It has to yield 50.
So that's a high-tech, high-capital version of intensive farming. But there is another version of intensive agriculture that is basically powered entirely by sweat, right?
You're talking about plantation agriculture.
Yes, and this one is fascinating because I think it breaks people's mental models.
It definitely does. Plantations happen on huge tracts of land, so people instinctively assume it must be extensive.
Because it's spread out.
Right, but it's not extensive at all. Plantations are usually found in developing nations, what we call the periphery or semi-periphery.
And they're growing cash crops.
Strictly cash crops for export. Coffee, tea, sugarcane, cotton.
Things we want, not necessarily things we need to survive.
Exactly. But here's the key nuance. The machine driving this massive system isn't a fleet of million-dollar tractors.
The machine is human labor.
Human labor.
Yeah.
In these specific regions, employing hundreds or thousands of workers is often cheaper than importing advanced machinery. So you have armies of people hand-picking coffee cherries in Brazil or cutting sugarcane with machetes.
Which means the input is incredibly high.
The input per acre is massive. It just happens to be manual labor instead of capital or technology. It is essentially a factory without a roof.
That really puts a totally different spin on your morning latte. You're drinking the direct result of a highly intensive human labor system.
You absolutely are.
So we have market gardening and plantations. Is there a third intensive style?
Yes, the classic mixed farm, mixed crop and livestock.
This is the picturesque old MacDonald farm.
Very common historically in Europe, like in France. It's a fully integrated cycle.
Explain the cycle.
You grow crops, like corn or soybeans, but you don't sell them to humans. You grow them specifically to feed your own animals on the farm.
And then the animals provide the fertilizer.
Exactly. The animal manure goes right back onto the fields to fertilize the next round of crops. It's a closed loop.
It sounds incredibly idyllic and sustainable.
It is sustainable, but it is relentless, exhausting work. You have to manage the complex biology of the plant crops and the biology of the animal herds simultaneously.
You're doing 2 full-time jobs.
Year-round labor. You never get a break. That intense, constant human management is exactly why it's classified as intensive agriculture.
Okay, so that's the downtown Tokyo approach. We are squeezing every drop of value out of the space we have, whether with technology, manual labor, or a closed biological loop.
Right.
Now let's pivot and look at the Montana ranch approach, extensive agriculture, where we just spread out,
The perfect starting point here is shifting cultivation.
also known as slash and burn.
Right.
Now, this definitely gets a bad rap in the media. We see photos of the Amazon rainforest burning on the news, and we immediately just think it's mindless destruction.
And at an industrial scale, it is highly destructive. But at its roots, there is a very sound indigenous logic to it.
Walk us through the logic. Why burn the forest?
Because in tropical rainforests, surprisingly, the actual soil is terrible.
Really? With all that lush green growth?
Yes, the constant heavy rain washes all the free nutrients out of the dirt. The soil itself is basically sterile. All the nutrients are physically locked inside the trees and the vegetation themselves.
Ah, so if you want to farm the land, you have to unlock the bank.
Exactly. You cut down a patch of vegetation and you burn it. The fire turns the plants into ash, and that ash immediately releases all those trapped nutrients down into the soil.
Creating a temporary layer of extremely fertile dirt.
Exactly. Then you can plant your crops there. But, and this is the massive catch, that fertilizer is gone in 2 or 3 years.
The rain washes it away again.
It does. Once the soil is depleted, you cannot farm there anymore. You have to move on. You literally shift to a new spot in the forest, burn a new patch, and let the old patch regrow for 20 years.
So why is this extensive?
Because to feed a relatively small group of people, you need a massive amount of total territory. You're only using a tiny fraction of your land at any one time while the rest recovers.
It works perfectly for small, isolated populations.
It's brilliant for small populations, but it becomes a catastrophic ecological disaster when you try to scale it up to feed millions, because the forest simply never gets a chance to recover.
Wow. Okay, so that is extensive farming in the wet tropics. What about those dry zones we talked about earlier? The places where crops basically refuse to grow?
That brings us to nomadic herding.
This feels less like a business and more like a pure survival strategy.
Because it is. If you are living in the arid steppes of Mongolia or the Sahel region in Africa, grass does not grow in one place year-round.
It's too dry.
Right. So you have to chase the salad bar, you have to move your animals, your sheep, your goats, your camels, constantly to find fresh grazing and water.
It's a seasonal migration.
Exactly. It's not aimless wandering. It's a highly calculated traditional route based on centuries of weather patterns.
And it's expensive because you're using thousands of miles of land.
Vast amounts of land, with virtually zero inputs other than human guidance. And keep in mind, this is almost always a subsistence practice. You are doing this to keep your family alive, not to sell meat to a supermarket for a huge profit.
But there is a commercial cousin to this practice, right? The cowboy version.
Yes, ranching. This is the commercial, profit-driven version of herding.
So we are talking Texas, Uruguay, Argentina, southern Brazil.
Exactly. In ranching, you own a legally defined massive tract of land, and you let the cattle graze on it to produce meat, hides, or wool for the global market.
It seems like the ultimate extensive system. You buy the land, put the cows out there, and just wait.
Historically, yes. The cows do all the heavy lifting of harvesting the grass over hundreds of acres.
But I feel a but coming.
There's a big but here.
Yeah.
And this is where we really have to end our tour of these systems, because ranching is undergoing a massive shift right now. The clean lines between extensive and intensive are starting to blur.
How so? What's changing?
The global market demands cheap, abundant meat. And traditional extensive ranching, letting a cow wander around a pasture for 2 years, getting fat on wild grass, is slow.
It takes time.
And it takes land. It's economically inefficient. So we are seeing a massive shift globally toward feedlots.
Okay, the CAFOs, concentrated animal feeding operations.
Right. What we're doing is taking an historically extensive practice raising cattle and forcing it into a highly intensive model.
Squeezing it into the Tokyo apartment.
Exactly. Instead of the cow walking miles to find its food, we put thousands of cows in small, concentrated pens, and we bring the food directly to them.
Corn, soy, antibiotics.
High-calorie inputs. It's a brutal efficiency equation. If the cow doesn't walk, it burns fewer calories. If it burns fewer calories, it gains weight much faster.
You are maximizing the output while minimizing the time and the land footprint.
It dramatically increases profit margins. But think about what we've actually done here. We've taken a biological organism that was evolutionary, designed to roam over thousands of acres, and we've compressed its entire existence into a few square feet of mud.
We are explicitly trading animal space for economic efficiency.
We're trading land for efficiency.
That really brings it all home. I mean, we started this deep dive talking about soil types and rain patterns, and we ended up looking at industrial feedlots. It really shows that modern agriculture isn't just about wrestling with nature anymore, it's about wrestling with economics.
It is entirely an economic and geographic negotiation. Whether it's that intensive market garden in California engineering the perfect shelf-stable tomato, or the slash-and-burn farmer in the Amazon just trying to get 3 years of crops to feed his family, or the feedlot manager in Texas looking at a spreadsheet, the system is always a negotiation.
A negotiation between the physical constraints of the planet and the growing demands of humanity.
Exactly. And the environment always sets the baseline rules.
And sometimes the planet drives a really hard bargain.
Always. And if I could leave you with one final thought to mull over, it's this. We are currently watching the globe move away from those natural, extensive systems toward these highly concentrated, intensive ones just to feed an exploding population. We are prioritizing efficiency and yield above absolutely everything else.
Because we have to feed 8 billion people.
Right. But the question is, as we steadily turn our traditional farms into concentrated biological factories, are we losing something fundamental about our connection to the living world?
That is definitely a question worth chewing on next time you are standing in the produce aisle or picking up a steak at the store.
Absolutely.
Thanks for taking the time to help us decode the map of our food today. It's been incredibly eye-opening.
It was my pleasure. Thanks for having the conversation.
And thank you to everyone listening to this deep dive. We will catch you on the next one.